We're going to ask our next panel to come up, but I would like anyone that worked on our advisory committee for the white paper, not everyone is here, but for those who are here, if you could stand up and be recognized, because you really helped us tremendously. Anybody here that was on our advisory committee? Jim? And finally, I would like to ask anybody that is on the Baywork board. It's our decision-making body. They had to approve funding for this event, for example. Anyone on our Baywork board here, if you could stand and be recognized. Panel 3, preparing for the future new tools, technologies, and workforce opportunities. And I believe first up is Steve Mixis.
Good afternoon, everyone. Am I on this way? So I'm going to be talking today, and basically I'm trying to spark interest on a lot of new technologies that are being used in Europe, Canada, East Coast. I'm not really seeing them pick up in California yet, but I've been known to delve into various technologies for collection systems. A little about me. I was an operations manager for Ross Valley Sanitary District for about 10 years, which was an amazing experience. Before that, I was a project manager at my uncle's company. It was a condition assessment / lining. We did all kinds of manhole rehab and condition assessment. So I got about 20 years of experience, and in that time, I've got several nicknames such as Batman with all the toys that I had at Ross Valley. So today I'm going to just briefly review mobile data mapping, also live digital communication, and then some new condition assessment technologies, and then training tools. And again, training tools are the most important aspect. You can have the best equipment, the best software in the world, but if you do not have a training program, you will fail. So one of the first things I highly recommend, and a lot of the agencies I'm working with right now, they don't have a CMMS, they think they do, but you want to get it right. You want to invest heavily, and it's got to be from the top down for the acquiring the money, but you have to involve your field staff, and we had a great time at Ross Valley. We worked with them on developing all the work orders and setting up the entire thing so they had buy-in. And that's why I think it was a big success at Ross Valley. So some of the cool ways you can actually map your data now is with augmented reality. Does anyone use augmented reality at their agency? And so basically you're using all your information in your GIS, and you can see on the picture, you can walk around with a tablet, a phone, a HoloLens, and watch all your assets in pipe in the ground. And it's basically live, and it's dead on with the GNSS unit that's on top. And you can literally, with your fingers, move pipe out in the field and to where it's supposed to be, or the manhole where it's supposed to be, and it'll update your ArcGIS online. So it's just so much quicker, and it's actually incredibly cheap. The other thing I'm very interested in is reality capture. So you used to be able to do this with like a $65,000 piece of equipment. This image actually was done with iPhone, I think 12, and it's called photogeometry, and you basically go around your trench when you have it open, or a vault, your force main, and you take hundreds of pictures and it'll stitch it all together, and it'll geolocate it so you can have a slider bar. And the still pictures don't do it justice. Look it up on vgis.io or YouTube, but it's amazing what you can capture. Again, here's another using your phone, and it is live out there. You'd just be walking around, and you'll see that trench right in the ground, and you'll know where all the laterals come in, any cross connections, where the water line is, and it just really helps you. And the data, it stays there. The other thing with VGIS is mixed reality. Trimbles has their own version of this, but you can walk around in the field and see all your manholes, your depths, where the pipes are, your storm drains, how they're coming around, and it gets even more incredible when you put on a Microsoft HoloLens 2. And you look kind of weird because you're out there doing your work orders with your fingers, but you can literally have your dashboard right in front of your head. And you can type in all you're typing in space, basically, and you're updating your GIS and all your asset inventory. And here's a little picture. You can literally walk around and see all your pipe defects on the asphalt, on your easements, and you can actually see, roots fine joint. You can see pictures of everything on the ground. And if you can't really understand until you actually experience it, but I do think this is the future. There's agencies in Europe using this, and basically the HoloLens, they embedded it and made it as safety glasses. So the operator can still be safe, have your hard hat on, and you can walk around and know where all your manholes are, your force main is, so it's quite an experience. The other thing I highly recommend, and we're helping a lot of agencies out, smaller agencies, is developing mobile applications for operations. And it's as simple as using, the Explorer app or Survey 123, the collector app. And you can tie it in, you don't have to buy the $30,000 CMMS. You can work with ArcGIS and all their apps. But we had an amazing system with a Geotab, our a GPS unit. And then we also had a fleet management software called Fleetio. And you're looking at $30 a vehicle, basically. And you're understanding exactly where they're driving, and it's live. So during an emergency, I could sit there on my phone while I'm driving, well, not while I'm driving, and I'd see all of my vehicles and the Vactors coming. I can see everything live. And having information is the most important for first responders. If you ever know anyone that's a fireman, they have so much technology, and they already know what's going on in the building that they're going to. And that's what we wanted to give our operators. So they had all the lateral cards, the lateral information. And the next thing, dashboards. Dashboards are so important. Every morning I got to Ross Valley, I had a 49-inch screen, and I had all my dashboards, and I knew exactly what everyone did the day before, and it was live. And again, we had some amazing talent and he's still there at Ross Valley, and he was able to incorporate our Geotab, our smart covers, and everything into one platform, so I didn't have like 8 screens. And then he used the Power BI. So if you're not using some of these systems, please contact SKL, or I can point you in the right direction. Okay, so live digital communication. I've tested this out with aerospace company. And basically, that's a HoloLens 2 on her head. And again, it's a hologram right next to you, and your supervisor or someone else could be right there and anywhere. So if you're in your pump station, it's hands-free, so you can get into your electrical panel and walk through what you're supposed to do. Again, a HoloLens, they have a 365 remote assist, and then the 365 guides. And you can basically scan a 5-horsepower pump, 400-horsepower pump, and you can create a hologram and basically take apart the entire pump and on a table. And if you have 4 different people around the table with HoloLenses on, you can actually see what the other person's taking apart. And you take them off, there's nothing there. But it's just, for training applications, I think it's going to be the next wave. And another fun thing, I was just showing my table, we scanned all our stations with Matterport, and it's the same as just doing a house scan for a home sale. So that's a 3-story building that creates a 3D model, and then you can actually put on VR goggles and walk through your whole station and operate, open up your lockout tagout, look through all your other SOPs. You can embed videos in it, and you can call your local realtor scanner. So this station costs, I think, $600 to scan the entire station, and then you receive the model and you put in these matter tags, and you have the ability to take 20 guys through a station without actually having the person go to the station. So that's another picture of a pump station 12. And the other good thing you can use Matterport for, or Leica 360, is for capital improvement projects for before and after and condition assessment. And the costs are just absolutely low. That station, I think, was $150 to scan. And then for outside mapping, the handheld versions are super cool. I didn't have the ability to get that yet, but I had the one on the left-hand side. And basically, it's an outdoor version of the Matterport. So we were able to scan easements and actually have a walkthrough of how the operator can actually bring the camera or the jet hose up the line or know exactly where that rod hole was. So LiDAR mapping, I think, is going to be huge, and the costs have come down absolutely dramatically. And then drones. I love drones. So basically, now they have drones that'll fly through storm drains, sanitary sewer. They're all pre-programmed flights. They'll understand where the obstacles are. And if there's anything wrong, they'll fly right back. And again, it's cheap. We're working right now on injecting hot air from a cured-in-place steam unit. And with a thermal camera on a drone, you can actually see, without smoke testing, you can see the hot air coming out of the ground, the manholes. And for anyone that has smoke tested, you know what a nightmare it is for doing public outreach. Well, imagine taking the smoke out of it. And then, wrong way. Training. And again, going back to training with holograms, there's some great videos I'll post on my website. But it's really cool, especially I was never a treatment plant person, but I think it has huge potential in treatment plants, pump stations, and anything mechanical. And then again, VR training, I think this is the last slide. And virtual reality training, a company called RIVR has done some amazing stuff for first responders, and I'll be working with them trying to create overflow response virtual reality trainings. And with that, any questions?
Great talk, Steve. I was wondering, have you used HoloLens for real-time performance support?
Yes. Yes, that's where it's, you can see a picture of it and it doesn't do it justice, but when you're actually using it and talking to someone in Kentucky and they're right next to you as a hologram, it's phenomenal.
For the GPS device, can you use that for like USA marking for AC transit pipe? The one that augmented reality? Do you understand what I'm talking about?
Well, if you locate it and with the rod, then you'll know where it is.
So you have to put it into the system first?
Correct.
Okay.
Yes, you have to have everything mapped, and that's what helps agencies that have bad data out in the field, and you can get your map changes done so much quicker. So much quicker, because it went from the little it was like 8 pieces of paper, authorizations, this and that, but it's just a lot quicker.
You mentioned some great tools there. How about the cost?
That's the cool part. When I first started some of these initiatives, it was totally cost prohibitive. But now there's, water and wastewater are one of the only industries that are not using some of these technologies. So I think there's going to be a massive ramp up, and just the potential, the costs have come down substantially, especially in the last 2 years. So when the HoloLens was $5,000, now it's like $2,000. And then the Office Dynamics, everything, the cost has come down so low because it's just such mainstream in the aerospace, petroleum industries. So the costs have definitely come down. And that's why now we can start using it.
I have lots of great ideas. I'm so excited. But on the HoloLens, how does that work if we have a certain type of pump? Does the manufacturer give that? How do you get the programming in there?
So you can do it yourself with the camera systems, and then basically you're creating a 3D model. You put it into a Revit or several different Autodesk products. You can do it in-house, but you figure if we all come together and we all create one model, there's only one 5-horsepower flight pump. You don't have to reinvent the wheel. So coming up with that library of different tools, you can literally scan an entire Vector 2100 series and walk around and dismantle it, or reduce it and I can put it on this podium. So there's all kinds of cool things, and it tracks every step of the training, and it's based on competency-based training.
Also, on the drones and the thermals, what's the smallest size that you know of for going in pipes?
Right now I think it's 15-inch.
1.5?
Yes, 15-inch.
Thank you.
So I'm sure they'll get smaller. I think there's going to be drones that will fly through your entire system in 5 years. without you having to open up anything, and creating 3D models the whole way, and I think condition assessment is going to completely change.
So we're back here. From the standpoint of training, are you using this for like emergency services training or scenarios of testing people, seeing what happens?
That's my game plan moving forward. Right now, I'm in a
Okay.
pilot phase, and basically, I want to be able to pull up to a site based anywhere in Google Street and put on and simulate an overflow coming out of a manhole, and then having an algorithm to see how much water is actually coming out of that manhole lid, and then having little dials that are holograms, and I can increase it from 1 gallon a minute to 200 gallons a minute.
Great. And then this is probably a loaded question, but I'll ask anyway. Do you see this kind of capability being used in testing for candidates and entry people coming in? In other words, assessing level of understanding and such?
There is, but there is I think it's 80% of people are good with VR. It's 20% get really nauseous, and it really messes them up.
Yeah.
But not me, I'm part of the 80.
We wouldn't want to say that the interview made him sick, but that, I understand. Thank you.
Thank you.
Okay, our next speaker is Andrew Ort. He's going to talk to us about cybersecurity. How many people think cybersecurity is a risk? All right, you're in the right room. From West Yost, Andrew?
So thank you all for being here and giving me an opportunity to speak. So this morning I was sitting through Shane's presentation and I was thinking about my experience with digital tools. And I realized that about 11 years ago, I had my first really profound experience with a digital tool. So I was living in Alaska. My wife and I had just had twin boys. They were about 3 months old. One of them caught a virus called RSV. And if you're familiar with that, right, it's really tough to breathe, especially if you're just a little baby. So we said, okay, we're going to the hospital. Now, Providence Hospital in Anchorage, Alaska, this was the same night that they rolled out their Epic electronic record management system. That was a bad time to show up with a baby who couldn't breathe. So, we get shuffled through, the waiting room very quickly, everything is good, and then we need medicine for the little boy. And I'm sitting there, I'm getting more agitated. I'm like, hey, doctor, can we get him some medicine? Doctor's like, well, we got to put it into the system, and the system has to approve it. And, they're typing away furiously, and it's not working. And I'm like, hey, doctor, you should really give him some medicine. And then, he's like, yeah, I get it. And then I go, doctor, give him the medicine. And the doctor goes, yeah, we got to give him some medicine. We'll figure out the paperwork later. So they gave him the medicine. Boy's fine, 11 years old, no big deal. But what it really illustrated to me in hindsight was that we have humans who are responsible, and they have to make the decisions, regardless of the tools that are being used, how they're being used, right? We are the licensed people as engineers, operators, et cetera, and therefore we are responsible. So with that, thank you. I'd never told that story in public before, so it was that's good. Yeah, thanks. Appreciate that. So cybersecurity, lots is changing in our sector right now. Who here is familiar with some of the new regulations that have been proposed around a new organization that will regulate cybersecurity in the water sector? Anyone familiar with that? Okay. Thank you, Jim. So, that's coming, and it's probably coming this year. So, in addition to that, right, we've the increased awareness from the Russian invasion of Ukraine. In December, as that was starting to loom, we started to get all of these advisories from Water ISAC, Department of Homeland Security, and it really, furthered the conversation that honestly really started with Oldsmar. Now, quick shout out to that operator at Oldsmar who caught that attack and fixed it, right? That guy deserves a gold star. And again, it comes back to the human being responsible. So, one of the things that's really changing here is that we, as the water sector, need a new group of people with a new set of skills. And we talked about that need. And if you go to cybersecurity conferences, they talk a lot about workforce development. So, and I'll come back to this kind of at the very end. But I'm curious, who here in all of their licensure, education, exams, everything else, who here has touched cybersecurity in some way? Who here has some responsibility for cybersecurity? All right, I would say we all do. So, with that, all right, so brief West Yoast, right? We are about 200 people, California focused, do have people from Hawaii now to the upper Midwest. Now, one thing is that we are licensed cybersecurity partners with Idaho National Laboratory. Who here is familiar with INL and the good things they do on cybersecurity? Anyone? Okay, so especially for asset owners, they have exceptional training opportunities. They have something called Red Team, Blue Team, and then they have something called Consequence-Driven Cyber-Informed Engineering, which is kind of a mouthful. We call it CCE. Really great opportunities to learn a lot. So, I propose that cybersecurity is everybody's problem, and we'll get into that in a little bit of detail. So, the evolution of engineering, right? Used to be we had things like wheels attached to carts, and that was groundbreaking at the time. Now, we have these elaborate systems, and they're all connected. Everything is networked. Almost everything is attached to the internet. Now, I know some of you are saying, our facilities are not attached to the internet. And I say to that, can you prove it? Some people can. Some people can prove it with a high degree of confidence even. But it's hard to maintain, especially as all of the vendors of the MCCs and everything else, they want to get data back. They want to harvest that data. They want to help you with your maintenance. They want to contract with you for that maintenance. That opens up new avenues into your networks. So there are emerging best practices. Some of these you, of course, have seen before. There are standards set by AWWA. Top 20 secure PLC coding practices. This is something every organization can do. You're probably doing it a little bit already, but there's really, really important things that you can get better at. OT monitoring, I'm going to come back to that. And cyber-informed engineering, I joined West Yoast about 3.5 years ago. I joined to do cyber-informed engineering. So, cyber-informed engineering, there's a lot on this slide. And mostly what I want you to take away is, a photo. That's perfect. But also I want it to be enshrined in the official record of the Baywork event. So, cyber-informed engineering, something that's really starting to emerge formally. And the intent is to change the way we engineer our systems to be more cyber resilient. So I met with a sanitary district yesterday, and we talked about this, and they went, oh, wow, we've been doing stuff so wrong for so long. And we said, everybody has, across sectors. But we have to get better. And there's this idea that, perhaps we can take everything we've learned over the last 100 years, come to today, make some really good decisions, so that perhaps for the next 100 years, we can be more cyber resilient. The cyber attacks, I don't like to get into the FUD, right? The fear, uncertainty, doom, doubt. I don't like to get too deep into that, but we do need to do better. And INL and the Department of Energy have recognized this to the point that there is going to be a national strategy document coming out sometime soon on CIE. The stated intent of this is so that engineers and owners will be held negligent if you do not consider cyber risk within your designs. So let's think about that statement and the enormity of that. I'm a licensed engineer. That makes me nervous. I'm sure it probably does some of you as well. Now, what's that? Yeah? Okay. So now we also have a big pile of money headed our way. All of us have, to some extent, ideas and designs. Some of those designs have been sitting on the shelf for a long time. Before cybersecurity was even really a consideration. In the national security documents, cyber didn't show up until 2009. I mean, that's when it hit that level of understanding. So as you all take those designs off the shelf and build them, or design new ones, cyber-informed engineering is something you really need to do. So I always like to point out active process defense. So I think it was Monty's example of the operator who would give that sludge a little sniff and a little feel, right? That is active process defense. You're monitoring the health of the system in many different ways. Combine that with something fancy like OT monitoring, and you can really create compelling data streams where you can monitor the health of your system and infrastructure. So this is the different elements. We're not going to get into it. Other than cybersecurity culture, who here has an organization that does phishing tests? All right, excellent. John, you should raise your hand. Yeah. So who here, and you don't have to raise your hand, has failed a phishing test? Oh, okay. I appreciate it. Oh, Sharon, yeah, I'm with you. I'm with you. So I do cybersecurity for a living. I failed a phishing test. I brought so much shame on my family that day. But it kept me very humble, right? And I can go and I can tell people like this, tell people about that. So there's lots of things. Some of these elements, a water wastewater utility honestly probably isn't going to be able to do it, at least for 5 or 10 years. Some of these other ones, you can do it today. Some of them you maybe already are doing. So I'm curious, who here considers themselves a defender of their system? Awesome, thank you. I agree. It is a mindset shift that we need to make as a sector, right? Our operators need to recognize that they are defenders now because the attack surface is global. So in about 2016, it was reported that the US Navy had decided to once again teach officer candidates how to navigate by the stars, right? Celestial navigation. You remember, you probably heard about a sextant at some point in your life. That's what they use for that. The reason they did this is they had realized that they were fully dependent on the global positioning system, and they could no longer be dependent 100% on that. So they went back hundreds of years. So I propose that we as a sector and as organizations, and take it a step further, communities and families, we have to decide what our celestial navigation is, and we have to go and do that, because our technology, there's a clear value proposition, and it's immense, but we have to have that backup. So with that, quick shout out, there's something called CyberChamp. For anybody who is trying to figure out how to staff and train, CyberChamp is an emerging tool. Just to give you a sense, we hire OT cybersecurity people, and when we have interns, we lose them to organizations like the NSA, INL, Bank of America, Ernst & Young, and Tesla. That's who we're competing with. You all will need to hire similar people. We need to grow a lot more of those people and train them. It's going to be a real challenge, and that's the same challenge across sectors. Linda. Thank you. Operations Technology. So that would come, maybe you call it a SCADA system or a DCS. Yep, thanks for the clarification. So here's some resources. Again, I just want to make sure they're in the official record. Thank you very much, everybody.
You talked about something that happened, I think, at Gold Star or something like that. What is that?
Oldsmar?
I guess so.
Yeah, okay. So Oldsmar is a small utility just south of Tampa, Florida. And a couple of days before the Super Bowl in 2021, they were hacked. And the operator observed someone moving the mouse around, and they increased some caustic, thank you, by 10,000, or something like that. And he said, wait a second. He's looking at it happening, and he said, this is not good. Oftentimes when we catch those sorts of things, it's because the attacker did something wrong. Had they done that at 1 in the morning, would anybody have noticed? No, because there was no alarm condition that went with it. So my understanding is that at the national level, there's a lot of concern that this could and will happen again. I mean, when it happened and it hit the news, my parents called me up and they said, Andrew, is the water safe to drink? I said, yes, Mom, yes, Dad. The water is safe. It just happened. And then I had to explain networking and air gapping and all of those concepts. And, it's kind of fun to have to explain that to my elderly parents. But anyways, Robert.
This is not so much a question, but a statement. And I know I'm dating myself with this, but you made me feel like I have to be Will Robertson of Lost in Space and become a defender of our space. So anyway, that's my comment.
Okay. That's a danger, Will Robinson.
And next, to talk about AI and other cool stuff is Jim Cooper.
Good afternoon, everyone. So I'm here to talk about artificial intelligence, and I know we have an exercise after this, but I'm technically the last presenter. They did that on purpose, so if any of you are just not interested, you can go ahead and leave, and you got all the content for the day. I hope to talk a little bit about AI. I'm going to talk a couple slides about what it can do, right? But that's not my entire presentation. The other 3 hours of my presentation are actually on how you can interact with AI. So because I am the last presenter, I guess I can talk for as long as I want to. No, I'm just kidding. So last presentation, going to get some audience participation here. Topic of artificial intelligence, right? Question, are you using it at all in your personal lives? Okay, let me ask a different question. Who has a smartphone? Right. Okay. Are you using it all in your work life? Yeah, yes or no? Okay. So we're going to talk a little bit about how AI can be used in your work life, but I really want you to think about why AI is coming and not think about, I've heard a number of presentations, not just today, but all over the place of AI is coming, we need to be ready, right? And it's not really that perspective that I try to bring. It's more that the way we work is changing, and in a few years, in a year, in 10 years, it's going to be used everywhere, so we need to prepare ourselves for it and understand why and how, and really truly understand what it is, not just have perceptions of what it is. Maybe? Okay, so let me start with this. The greatest challenges we face in the water sector have absolutely changed over time. It wasn't that long ago, within many of our lifetimes, especially with some of the durations that people work here in the Bay Area, that engineering and designing looked like what you see on the screen there, with people that spent days and months drawing out city blocks and water mains and wastewater information, right? That was the most significant amount of the time, was actually drawing it out. Then technology like AutoCAD and CAD and BIM came along and took what would take months and put it into taking days and hours. And now we're at the point where those things can be fully automated, right? So they happen in seconds and minutes. So I think the greatest challenge we face today, or one of the greatest challenges, is working with data, right? I talk to many utilities, and many times they don't have access to the data that they need to make decisions, even though the utility is collecting it. Or they spend days and months trying to actually get access and figure out who owns or who's maintaining that data, what's the quality of that data, right? I think people think we're probably swimming through a data lake, right? We have too much data, and we're not even actually using it. Actually, there's a couple studies that came out in the one specific to the water sector. Anyone have a guess of what percentage of data that's being collected by water utilities is actually being used? So it's about, ever. So it's about 10%. 10% of the data being collected is actually used in a meaningful way in the water sector. There's a separate study by the Harvard Business Review that looked at what percentage of data being collected in the industrial world meets basic quality standards so that you should actually use it to make decisions. Anyone know what percentage of data meets basic quality standards? It's about 10% as well, right? So here we're talking about using data, we're talking about cybersecurity, we're talking about sensors and technology supplementing our workforce, yet we only use 10% of the data that we have access to today, and only 10% of the data really meets quality standards that we should trust it to make those decisions. So a potential significant challenge. So I might ask the question, well, how much more data could we possibly need in the water sector, right? We've got all this data, how much more could we get there, right? It's really about analytics. Well, I think, maybe to phrase it another way, I think we're truly only beginning in the amount of data we're going to be collecting and using in the water sector. So I wonder how long it is before your frontline staff, your operators, make a statement like this, right? I cannot operate or manage any individual asset without a live data stream for that specific asset. Now, if we think about pumps, obviously we have that today, right? But think about maybe individual segments of pipe or an individual hydrant or, a force main, et cetera. I think when we think about data, there's a whole world out there. I think that's really one of the primary drivers of why technology like AR and VR, the importance of cybersecurity, artificial intelligence, machine learning is going to be more embraced in the water sector as we move forward, because we have to have a tool that allows us to use that data and manage data. So I'm going to talk a couple things here real quick, and I do have a ton of slides, so I'm going to get through them kind of quick. When I talk about artificial intelligence, if I were to put a definition to it, I define that as the ability of a machine to sense, reason, engage, and learn in a manner that seems intelligent. A lot of people out there, a lot of companies out there have what's called machine learning, which I'm sure we've all heard of, and they call that artificial intelligence. In my opinion, that's just one piece of it. You don't have artificial intelligence if you have machine learning, right? That's like going out and buying 4 tires and say you have a brand new car, when you can't really go very far. On the other hand, there's a term called collective intelligence. And that's the ability of humans and machines to collectively present a far greater solution to any problem than they could on their own. It's not just some fancy term that I came up with and we said it sounds great. There's an entire center at MIT that this is all they focus on. It's a Center for Collective Intelligence. They've presented hundreds and hundreds of problems. They take a room full of subject matter experts just like this, present a problem, tell them to come up with a solution. They present that same problem to a supercomputer to come up with a solution. In no instance have either group, the computer or the subject matter experts, come up with the best solution compared to when they allow the people to interact with the computer. And then that's the whole idea behind collective intelligence. So I'm gonna give a practical example. This is truly just an eye test for people in the back, so there'll be a quiz later. But if you think about going out and making a decision to replace a pipe, right? There's a lot of things that might go into your mind as a human to replace that pipe. I put it in these 4 different little buckets that you see. One is the asset representation models. So your GIS, all your physical attributes, the age, condition, diameter, et cetera. There's physics-based models, right? So computer hydraulic models or water quality models or process models that are gonna look at the operational conditions of that asset. There's also what I would call data-driven models that we traditionally associate with machine learning or AI, like looking at risk and predicting pipe risk for an individual asset, looking at lead service lines or predictive maintenance, et cetera. And then there's optimization models that might look at energy optimization, greenhouse gas reduction, right? We have all these different things. It's on us as the end user to kind of put all those together and say, okay, well, this one thing saying this other thing saying this, I guess we should make this pipe, a certain size. Or it actually doesn't even need replaced. Let's just keep it there. It's worked great for the past 100 years. Let's not change it. That's where technology can truly come in. Let the computer make all those connections between all those systems, right? Let the user have a dashboard that they can create, that they can get insight out of that, right? Let the computer work on the back end. At the end of the day, the computer is not replacing the person, right? It's just making their decisions much more stronger and much more valuable to the overall utility and to your customers. I told you I was going to have one slide that talks about applications of AI. I was just working with a utility that wanted to see where they could put AI in their water treatment facility. So this was just a quick list we came up with. I thought I'd share. Certainly not going to go through all this, but there's tons of opportunity where AI can be used and is being used across the water sector. So a couple examples: asset health twins, operational data streams, environmental data streams. One of the ways where we're seeing blockchain being used, because someone asked, is in security twins, where you have a distributed ledger, which is what we think of when we think of blockchain, that has a 100% complete record of all both physical and digital systems that you have. Their uptime, who's using them and accessing them, you have all that information. So there's a lot of opportunities out there where this is being used. So ask the question, are we swimming through a data lake? I truly believe we're only diving in right now into where we're going to be with the use of data, and we need to think about what are the tools and technologies that we have to actually use that data in a meaningful way. I'm going to leave you with 4 key points in about 10 seconds, so hang on. Data is evolving. I think most people in this room is probably going to think about data as spreadsheets, numbers, letters, databases, right? When I think about data, I think about a camera that's thermal imaging on the series of pumps and using computer vision to detect when the thermal footprint of some sort of physical asset changes, or a sound device in a facility that is sensing when you have a change there, right? We need to think differently about what we think about for data. Next is AI doesn't address our needs. People do, right? AI is not here to replace anybody. People enabled by new technology is what we call collective intelligence. Now, it's nothing different than when the water sector first started using spreadsheets, or when SCADA was implemented in the water sector. I think everyone probably had the same thoughts then that they do now about AI, right? And I think we've seen it's only enabled what we've done. I could be up here talking about how, maybe 30 years ago, we're all going to, on a normal daily basis in our jobs, be required to use the internet. I think everyone would probably say, yeah, right? Well, here we are. AI is no different than that, and probably will be coming in a much greater pace than the internet was. Will AI replace our workforce? Absolutely not, right? It allows us to make better decisions without it. Our table, we were talking about, one of the concepts that I try to get through when we're talking with utilities is you must have a human in the loop. If you're an IT guy, if you're an instrumentation and control guy, you think about control processes, there has to be a human in the loop, right, with your process. I could talk on and on for many different things. Happy to talk afterwards. I'm out of time and over a little bit, so I'm gonna be quiet, but I do have a couple real quick minor things. Who here thinks that piloting is an important step when you implement technology? Hey, I think that's the most people have raised their hand on a question today. Pilot people, not technology. The technology is already proven. You need to pilot how your people interact with the technology, how they work with the technology, and what you get out of it. So, with that, thank you.
So James, just a very quick question from your perspective. AI is a very powerful tool, but there's a lot of concern about what it returns in terms of answers. So the question is, how do we believe that what we're seeing is correct? And what are your thoughts on that?
Yeah, absolutely. So a lot of people have the misconception that AI is a magical black box, right? We're just going to give it data, we're going to install some new sensors, and it's going to tell us what to do, right? I think that couldn't be further from the truth. All it is an algorithm or a series of algorithms. It's very simple. I'm not going into all the different technical applications and what goes into AI, but I think of it no different than you using solver or regression analysis in a spreadsheet, right? It's just a different way of doing things and a different set of algorithms. It can very easily give you an answer that's the wrong answer, right? It's not going to give you the right answer every time. It's on us as the people to evaluate that data and make the final decisions.
How do you think systems or processes as autonomous vehicles can help us embrace AI's capabilities?
That is a great question. So truly, we could have a whole day presentation just about AI. And one of the subsections of that day would be about the moral implications of AI. So I'm going to answer your question in somewhat of a unique way. There's a website out there where you can, it presents two situations with a self-driving car, right? And you, as a human, decide which is favorable versus the other, right? And the situations are, for example, the brakes go out on your car. Does the car run through an intersection, or does it steer off into a building and crash, right? And then it says, okay, well, there's a grandma and a baby walking through the intersection, right? There's thousands of these cases. So there's this whole world out there of moral implications of AI, where if you get into thinking about automation and autonomy of AI, I think we're pretty far away from that in the water sector, because no one, whether it's us people, whether it's regulators, whether it's the public, is going to allow AI to make moral decisions on drinking water and public safety. I think that's a significant thing we need to understand. Again, just the reality of what we think AI might actually be versus how we can actually use it practically grounded to pick a pipe are two very different things many times.